Yep. Oops. So yeah, I will try to give you in 10 minutes a quick overview how we have combined available data and models to achieve a better evaluation of management strategies, or not better, or more holistic evaluation. And the general question or the general problem is quite clear. So we all know management strategy evaluations, but normally they focus on one single stock. So the question is, can we extend MSE simulations to cover a much broader range of objectives and indicators relevant for EBFM? And then finally, can we identify win-win and trade-off situations to provide guidance on suitable management measures? Our approach was similar to many other case studies in CWISE. We had a bioeconomic model FL-BIA as the baseline or the central model to simulate mixed demersal fisheries under the landing obligation and all the nice choke effects. And then we had several EBFM extensions. So we first looked at environmental impacts on recruitment under climate change. Second, we made a link to a multi-species model SMS to get also an idea what happens to our pelagic and forage fish stocks. We made a link output of FL-BIA to the ecosystem model stress E2E to look at more the wider ecosystem aspects. And we also made links to other data, for example, to analysis on the relative benthic status we have already heard about, or for example, landings by port. And finally, of course, we also had to look at the economics and the impact of our management strategies on other indicators. To give you a bit more details, so our FL-BIA model has more than 100 fleets and métiers, and it covers the 10 most commercially important fish stocks, gadoids and flatfish species, and also 10 NAFROS functional units. It is officially used in ICES, and it is parameterized based on year 22. We simulated 3 standard management strategies you have already seen: status quo effort as a baseline, and then FMSY-min, with FMSY-min as the upper limit, and the landing obligation, and then a more flexible, pretty good yield scenario where you can also go above FMSY if your stock is in good shape. And then we get the standard indicators that we all know from MSEs. And here's the first result is, apart from the status quo scenario, all the scenarios tested in the final end achieve less than 5% risk to fall below the limit, so it is precautionary. But we also see that many stocks in these scenarios are fished below FMSY. So what does this mean? Then if we look at the external ecological drivers, so we used the machine learning framework to identify what is driving recruitment of important stocks. And we also looked at the predictive power of our models, so not just the fit to historic data. And in the final, we identified a clear negative effect for cod and saithe. It's really going down the productivity, a positive effect for whiting, and for flatfish stocks like plaice, it was more undecided. So if we put this now back into FL-BIA model, then we see 3 things. First, climate change has a clear negative effect. So we lose SSB and catch. Second, we see that our PGY-min and FMSY-min scenario can keep the stocks above reference point level. So this is good. But on the contrary, we will lose catches again, and especially under FMSY-min. However, the pretty good yield scenario, PGY, is maybe some trade-off strategy and could be a compromise between status quo and FMSY-min. So if we now look at the link to the stochastic multi-species model SMS, so it is not only simulating fishing mortalities, but also predation mortalities. It is used in ICES, so-called key runs to inform single stock assessments. And it uses standard stock assessment input data plus 250,000 stomachs sampled mainly in the period 81 to 91, so quite old, but that's what is available for the North Sea. So then our FL-BIA model predicts the F on the predators, and then SMS predicts what our predators will do, how far they will improve. And then we can look at the predation impact on forage fish and how this forage fish will do under certain fishing strategies, for example, an escapement strategy for sand eel or FMSY for herring. And then finally, we can look at the forage fish indicators, the famous 1/3 for the bird indicator from Korea et al. And see in our example, on average, it seems to work. We can keep the stocks above the thresholds, but this does not mean that this will happen in all years. So if you would also look at the risks and more uncertainties, then you would see that you can fall under this threshold in some years. Now, the link to the ecosystem. So we had the stress E2E model, and it had 26 skills, so the entire ecosystem from phytoplankton to whales. It also had several fishing métiers, pelagic and demersal fisheries. And what I want to highlight, it also has environmental drivers extracting from global physical biochemical models. And with this, we can also look at, for example, changes in nutrient fluxes under climate change, what is different to many of the other models we had in the case study. If we look at typical ecosystem indicators, then we see, of course, under the strict FMSY scenario with low fishing effort, we get a lower bycatch of pinnipeds, we get a lower swept area ratio, and we get a higher ecosystem mean trophic level, so everything is fine. A lot of win-win situations compared to status quo, and again, our pretty good yield scenario is somewhere in between the both. If we look at the climate change effect, then we see now here a real bottom-up effect cascading through the whole ecosystem, from primary production to seabirds. And of course, this can be quite different to the model, to the other models that are more focusing on top-down processes. So maybe with these models, we are even too optimistic compared to what the ecosystem model predicts. So, of course, everybody wants to hear something about seafloor impacts under EBFM. So we have a calculation of RBS for current effort levels and spatial effort distributions. We have heard about it in other talks. And then the effort buyer model predicts effort trajectories under the different management strategies. And then we can recalculate the RBS. And for this, we had to link the effort buyer métiers to Bentys métiers, what was quite complex, but I think in the final end, we succeeded. And if you look at the results, so under the assumptions that good environmental status is achieved, if you have more than 75% of an habitat, North Sea-wide habitat area above this RBS threshold, then it is good. Then we see with an RBS threshold of 0.8, both scenarios, FMSY-min and PGY-min, bring us into the green zone. So this is good. However, if we would choose an RBS threshold of 0.9, even the most strict scenario is not able to bring it in GIS for all habitat types. So last but not least, the long-term socioeconomic impacts, as I said, under PGY-min and FMSY-min, we fish stocks well below FMSY. So does it matter? Well, it has some relevance for food security because we lose catches, I already said. And this is compared to the status quo scenario. And of course, then even we also see the negative effect of climate change. But if you look at the economic performance or at wages, then we see that the PGY scenario outperforms the status quo. So here it is more a win-win situation. And of course, also for carbon footprint. If you have FMSY-min with low fishing effort, then the carbon footprint will be lower. So that's also good. Last but not least, we also linked model outputs to RDBS data in ICES, where we have landings by port. So for each port, we can calculate whether it will win or lose under a certain management strategy. What we see here is, again, the negative effect of climate change, and also that the PGY scenario performs best. And FMSY-min is second, and status quo is the worst. And we can do much more analysis in future projects with this. So I think this is a very valuable link of available data. So to conclude, we demonstrated that it is possible. Yes, we can. But of course, we have structure uncertainties in all models, and we can discuss for years on parameters. So before we give advice, I would say we should go to benchmarks in institutions like ICES. We have used a large set of indicators used to provide a holistic picture. And we have seen that management based on MSY in combination with a strict implementation of the online obligation leads to a lot of win-win situation, but also to trade-off, especially, for example, with an indicator like food security. The GIS thresholds are still often under discussions, and we have seen, like for RBS, we have to be careful. We can kill fisheries, no doubt about that. And therefore, for this, we also need technical measures to improve the situations. And we have also seen under climate change that we have looked at the traditional species, but of course we know that there are new fisheries coming, like for squid and cuttlefish, but it is too early to say whether they can really compensate for losses from these traditional species. But there is hope and also a lot of new challenges for new projects. Thanks for your attention.